All right, so I'm going to go through two more examples with you of single radical equations. That way you can see them and kind of make sure you know what you're doing before we move into our double radical equations. So again, the first thing you want to do is always make sure you get this radical by itself. All right, so we're going to do one at a time. I'm just going to mark off both of these for right now. So anything added, subtracted, multiplied, divided to that radical, we need to get rid of before we can do anything else. So I notice I have this -1 here. I'm going to add 1 to both sides, get rid of that. So now my radical, my third root here, is completely by itself. And again, I knew that -1 was not underneath the radical symbol, so we were good to move it. Now in this case, to get rid of our cube root, we're going to raise it to the third power. Remember, your root and your power, as long as they match, if the index matches with the power, they're going to cancel out. So only the inside drops down. 2 cubed is 8. Oh, my bad. Let's go back for a moment. That's not 2. 2 plus 1 is 3. My mistake. And now 3 cubed is 27. From here, there should be no issues with how to solve this. It's a two-step equation, and you are going to end up getting x equals 18. Once you have your value, you can't always assume that your value actually works within there. Remember, we have what is called extraneous solutions, solutions that work to what you solved, but maybe not in the actual problem. Now, this will most likely occur when you're solving quadratics or other polynomials, but you should just get in the habit of checking anyway. It just makes sure that you got the right answer. So you take your 18, plug it back in, and you go back to the original equation. And it's just a matter of simplifying it. So I would do the inside. 2 times 18 is 36. 36 minus 9 gets me the cube root of 27. All right. Oops. It should be -1. And then cube root of 27 is 3. 3 minus 1 is 2. 2 equals 2. I run out of space. It does work out. Okay, so I do know that this is my answer. All right. Now for part B, or for the second part, I should say, you want to do the same thing. If I had anything added or subtracted with that radical, I would have to move it. There's nothing there. So I can jump right into the squaring. It's a square root, so I'm going to square it. Again, the root and the index will cancel. So 10x plus 9 drops out. And then I have x plus 3 squared. Remember, that means you have to write it twice, and you're going to FOIL it out. So this becomes 10x plus 9 equals x squared plus 6x plus 9 once you do your multiplication out this way. From here, anytime you have a quadratic, you want to get one side to be 0. It's the only way you're going to be able to solve it realistically, by your square root method, by your quadratic formula, by factoring, all those methods. We want to have it equal to 0 before we can do anything else. So I'm simply going to move the x and that 9 over. I'm left with x squared minus 4x. Those 9's canceled. Now from here, it's easy to factor. I could factor out an x. I'm left with x minus 4. And then I could solve each of these. X equals 0. X minus 4 equals 0. Well, this one's done, and this one becomes x equals 4. So those are my two answers. Don't know if they're both legit or if I have extraneous ones. So I am going to check it. And I'll do my check over here. So I'm going to start with x equals 0. Put a 0 back into the original. Again, you're going to put it exactly where you would see the values with your x in both sides, and you simplify both. 10 times 0 is 0. 0 plus 9 is 9, so the square root of 9. 0 plus 3 is 3. Square root of 9 is 3. So it works out. So 0, definitely an answer. Then I'm going to check x equals 4. Again, go back to the original, plug it in, simplify one side, and then simplify the other. 10 times 4 is 40, 40 plus 9, so I have the square root of 49. 4 plus 3 is 7, square root of 49 is 7. So this one works out also. So in this case, we had both of them work, whereas in the class, we did have some that were extraneous. When we plugged it back in, it did not make sense in the problem. Okay, so hopefully these extra examples helped you out.